With respect to application of differentiation, you have multiple concepts in this chapter. And all are pretty simple chapters. What you need to basically know before we can start off this chapter is how to differentiate functions, the chain rule, and how to deal with algebraic and trigonometric functions. If you know that, this chapter is a cakewalk. There's nothing difficult about this chapter. So, under application of differentiation, we have tangents and normals. So we have tangents and normals. And we also have increasing and decreasing function. And maxima, minima. Now, what do we have under tangents and normals? Basically, you will be given any one of the four, which is the point, the slope, or even the equation of the tangent, and the equation of curve. So from this, any three will be given and you will have to find a fourth. For example, they might give you a point, slope, and the equation. You have to find the equation. If equation of curve, this will come under, this option will come under integration, not in here. So probably they will give you equation of a curve and probably the point. You will have to find the equation of the tangent. That is possible. You find the slope and then you find the equation of the tangent. So that's all is there. One of the important questions from this is an NCERT question which says 8k square is equal to 1. Under here, you will also learn the concept of orthogonal curves. This concept is not there for NCERT, but yeah, it's a nice concept to know. Under the same, you will also learn something known as angle between two curves. So these are things that you will learn under tangent normal. Basically finding the equation for tangent, finding the equation for normal, and the remaining things. Now, what do you have under increasing and decreasing functions? Under increasing and decreasing functions, you will basically find out when is a function increasing and when is a function decreasing. Mainly that. Now, you will have algebraic equations here, or you will have trigonometric equations. Algebraic equations, degree 2 or a degree 3, a cubic equation or a quadratic, a trigonometric, a little bit of tough questions are there. You need to learn how to do that and then you're good to go. When we come to maxima and minima, there are a couple of things that we need to know. One is the local maxima. The working rule for local maxima is different and local minima is different. Absolute maxima and absolute minima. Again, the working rule for this is different. And then we have the global maxima and global minima. Global maxima and global minima. For absolute maxima and absolute minima, I'm going to draw these, which says included interval. Very important to remember. If the brackets are closed, if the intervals is closed, then you need to solve it using absolute maxima and absolute minima concept. Along with this, we have the word problems. For this examination, at least, you're not going to get very complicated three-dimensional objects like a cone or a cylinder or something like that. It's going to be very simple 2D figures like a square or a rectangle or any kind of a shape. The goal for today, the aim for today is to look at all of these and hopefully try to solve some questions. Okay. So let's directly look at tangents and normals. What do we have under tangents? Y-axis, x-axis. Let's say this is a curve. There's a point here. I draw a line touching the curve at this particular point. This line is said to be the tangent to the curve f of x. Y is equal to f of x. This is some y is equal to mx plus c. And this point, which is x1, y1, is known as the point of contact. This is the tangent. The tangent can have lot of lines perpendicular to it, innumerable lines perpendicular to it, but a line which is perpendicular to the tangent at the point of contact, this line is known as a normal. This line is known as a normal, and the equation of the normal is that. Now, why do I write this? Because I know that when two lines are perpendicular, the slopes, the product of the slopes has to be a -1, and therefore the perpendicular slope will be a negative reciprocal. How do I find the slope? Differentiate the function, substitute the point, and then you find the slope. That is all. Rate measure anyways you don't have, so you don't need to break your head on that. Okay. Very simple question here. Find the point at which the tangent has its slope. Not very difficult. You just need to differentiate, and dy by dx will give me the slope. That is all. So when you differentiate, you get the slope. Now, if you have doubts with respect to differentiation, that you need to figure it out. Probably you can solve some questions and then make sure that you're thorough with differentiation. Okay. You equate that to the slope and you get the x value. Now that's the x value. You get the y value by substituting it in this equation. Very simple. So you find the point. So here the equation of the curve was given to you, the slope was given to you, and then they asked you for the point of intersection. Now, this question, example 17, I have seen this question in multiple sample papers. You can do this in two different ways. The question says find the points in the curve where so and so, at which the tangents are parallel to the x-axis and parallel to the y-axis. Obviously, you go ahead and differentiate this, and then you say dy by dx. So you can see that he also says that the tangent is parallel to x-axis and the slope is 0. So he equates the slopes to 0 and then goes ahead solving the question. What I'm going to do is this, x squared by a squared plus y squared by 25, x squared by 4 plus y squared by 25 equal to 1. Now that's the equation of an ellipse. This is an equation of an ellipse. And I know that b square is greater than a square. And therefore I also know that this is going to be a vertical ellipse. That's all. Now, what I also know that a is equal to 2 and b is equal to 5. Which means the vertices of this ellipse is a dash, b dash. This is 5, 0 and this is minus 5, 0. No, this is not 5, 0. This is 0, 5, sorry. And this is 0, minus 5. And this is going to be 2, 0 and this is minus 2, 0. If I know this, I directly know that if the tangent has to be parallel to the y-axis, it has to be at this point. That. And if the tangent has to be parallel to the x-axis, then the tangent has to be at this point. Now, what's the equation of this line? Well, this line is at a distance of 2 units from the origin, and therefore this is x equal to 2. Similarly, this is x equal to minus 2, and this is y is equal to minus 5, and this is y equal to 5, and you're done. A very simple way of solving this question. Because you're gonna be dealing with MCQs, you can do this quickly and you'll be done with the question. Otherwise, if you want to say that no, I want to stick with the method, you can go ahead and do that. You can simply differentiate this function, 2x by 4 and 2y by 25, y1 is equal to 0, and then you get the value for y1 and then you continue with it. Now, what's the steps if in case you're looking for some steps of solution? The first step is to differentiate the function. Differentiate the function. Now, the second step is dy by dx at that particular point x1 comma y1. Now this is to find the equation of the tangent itself. That's the slope. He would have given you the point a comma b. Let's take the point as a comma b is the point. So in this case, it's going to be dy by dx at a comma b. Then I get the slope. This is the point. So what do you do now? You use the point slope form. What's the point slope form of an equation of a line? Y minus y1 is equal to m into x minus x1. So in this case, it's going to be y minus b is equal to m into x minus a. That's the steps of solution to find the equation of a tangent to a curve when the point is given to you. I'm going to pick up one question here, which is an example 18 from the textbook. So the question says y is equal to x minus 7 divided by x minus 2 into x minus 3. Find the equation of the tangent. I'm reading out the question to you. Find the equation of the tangent to the curve at the point where it cuts the x-axis. Very important. In here, he has not given you the point directly, but he has given you some hints about the point, let's say. So you need to find the slope. So you differentiate the function. When you're differentiating, you're applying u by v rule. Please make sure that you know your differentiation very well. Do not get overconfident at this place saying that, oh, okay, it's just u by v. I know what to do, and then you will go wrong in this, and then that's it. V differentiation of u minus u differentiation of v. Now, when you're differentiating v, it's a u into v rule. So what do you do then? U differentiation of v plus v differentiation of u, and that's divided by v square. Now what? I need to find the equation of the tangent when the curve is cutting the x-axis. That's what he says. When it cuts the x-axis. When this curve is cutting the x-axis, the y-coordinate is going to be 0. Understand that. When the curve cuts the x-axis, this particular point, the y-coordinate is going to be a 0. And that's what I'm going to use here. So if the y-coordinate becomes 0, when, if I can call this as 1 cuts x-axis, y is equal to 0. Therefore, x minus 7 divided by x minus 2 into x minus 3 is going to be equal to 0, which means x minus 7 is equal to 0, x is equal to 7. dy by dx at the point x equal to 7 is equal to, you don't need to substitute every point and then check. So 7 minus 2 is a 5, 7 minus 3 is a 4, minus, this is a 7 minus 7, so this entire factor is going to vanish. So I don't need to write that. I'll write a 0 here, divided by 5 into 4 the whole square. 5 into 4 the whole square. Obviously 5 into 4 and 5 into 4 will get cancelled, so you'll get a 1 over 20. That's your slope. Therefore, m is equal to 1 over 20. Now what do you do? Well, he is asking for the equation of the tangent. You know the x coordinate, you also know the y coordinate. The y coordinate is simply 0. Therefore, equation of the tangent at the slope, this, and the coordinates is 7, 0, is simply y minus y1 is equal to m into x minus x1. You solve this and you get the answer, and you're done with it. If this question was given to you in a subjective, question paper, I wouldn't do this. I would be much more systematic. But here we are just understanding how to go about solving the question. So I'm doing the quick way of solving the question. That's all. Another interesting question, which is example 20. This is a parametric function. Find the equation for tangent to the curve given by so and so. It's a parametric function. So you need to first find out the point. The point is given to you as t equal to pi by 2. So you need to also know how to differentiate a parametric function. dy by dx will be dy by dt divided by dx by dt. Please remember that. So when you differentiate, you get that, and you substitute t equal to pi by 2, you get the slope. And what happens to the point? Here's the problem with this. What happens to the point? You need to go back to the parametric function and substitute that value for t as pi by 2 in this case and pi by 2 in this case. So obviously you're going to get a comma 0, because sine pi by 2 is a 1 and cos pi by 2 will be a 0. So now you have the slope and you have the point, and then you go ahead and solve the question. And that's pretty simple. Y minus y1 is equal to m into x minus x1. All these questions are pretty simple. You can see here, example, or question number 7. Find the points on the tangent to the curve. He is asking for the points, not that he is asking for the tangent. He is asking for the points, where the tangent is parallel to the x-axis. Now, you also need to have an idea as to what happens when the tangent is parallel to the x-axis. What happens to the slope? When the tangent is parallel to the x-axis, the slope is 0. Parallel to the y-axis, slope is infinity. I'm going to pick up question number 13, which I solved using a very simple method. This time I'm going to use this to solve it using differentiation. The only reason being, I want to show you how to work with finding the tangent when it's parallel to the y-axis. That's all. Okay. So x squared by 9 plus y squared by 16 equal to 1. Again, here a is 3. A is 3 and b is 4. So I know that this is a vertical ellipse. So I already know the answer. This is parallel to the x-axis. So this is going to be x equal to 3 and x equal to minus 3. And this is parallel to the y-axis, x-axis, sorry. So this is y equal to minus 4 and this is y equal to 4. And I'm done. Not to worry. You can use this and answer the question, MCQ question. But if I had to differentiate, what would I do? I would say 2x by 9 plus 2y by 16. y1 is equal to 0. Transposing this to the right hand side, so I'll have 2y by 16. y1 is equal to minus 2x by 9. So when I solve this, I'll have minus 2x by 9 into 16 by 2y. 2 and 2 get cancelled, so y1 is equal to minus 16x by 9y. Now that's going to be your slope. That's going to be your slope. Therefore, now I'm going to go to the scenario where it says parallel to y-axis. The slope is going to be not defined, which means you will have minus of 16x by 9y as equal to not defined. Now here's the trick. How do you deal with this? You take the reciprocal on either side. So when you take the reciprocal, you will have that as that. Remember this, 1 over 0 is infinity and 1 over infinity is going to be a 0. Just transposing it like that. And therefore, I have 1 over infinity over here. This becomes a 0. This becomes a 0. And what will I have? I will have minus 9y by 16x as equal to 0. After this, solving it is very simple. You transpose this, so you get y is equal to 0. Now that's the point where the tangent is parallel to the y-axis, where y is equal to 0. Now when y is equal to 0, what's going to be the value for x? You need to go back and find it out from here. The value for x is going to be x is equal to plus or minus 3. And that's what you get here also, minus 3 and plus 3. Okay. So that's about, tangents and normals. There's nothing difficult. No question is going to be very difficult here. All are pretty simple questions. Find the points on the curve which is parallel to the x-axis. Take the slope as equal to 0. You should be done with that. These questions where the equation of the tangent is given to you and parallel to the line, from here you convert this to y is equal to mx plus c format. When you convert this to y is equal to mx plus c format, you will get the slope, which is 2. You use the slope, differentiate the function, equate it, and you're done. As I said, one of the questions, which is this, prove that the curves cut at right angles. If this was not a objective type question, and if it was a subjective type question paper, then the chances of this question coming in your question paper was far more higher. Okay, so what I'm going to do is to teach you how to find the point of intersection between two curves. Okay, how to find the point of intersection between two curves, and then also teach you how to find the equation of or the angle between the two curves. What I'm going to do is to plot a equation. Let's say x square equal to 15y. That's the first equation. Okay, x square, let's say x minus 1 equal to 15y. Now that's my first equation. Okay, and I'm now going to plot the second equation, which I will say is y minus 1 the whole square is equal to 15 into x. I'm just plotting some equations, okay, just to show you, what is meant by angle between two curves. So in this case, you can see that there are two equations, red and blue, that's been plotted, and this is the point of intersection of the two curves. Now I can have a tangent to the red line. Something like that. Or I can have a tangent to the blue line, something like that. Let me take this on a different application and show it to you. There you go. Now that's the equations that I had on Desmos. I've brought it onto the Word document so that I can draw some straight lines for you. So in this case, if I'm drawing a straight line, which is basically a tangent to the curve, the tangent to the curve is going to look something like this. That will be the tangent to the red line. And again, I can have another tangent to the blue curve. The tangent to the blue curve could be something like that. Now, what I'm talking about is the angle between the two lines. The angle between the two lines can simply be the angle between the two tangents. So this angle, which is the angle between the two tangents, is what I'm interested in. Okay, that's the angle that I'm trying to find. That is defined as the angle between the two curves, curve 1 and curve 2. So how do I go about doing that? I'm going to take the same equations that I plotted. So the first equation that I have is x minus 1 the whole square is equal to 15y minus 6, and then I have y minus 1 the whole square is equal to 15x minus 6. So how do we do this? Well, we differentiate. Now, for me to find the slopes, I need a point, basically the tangent at the point of contact. So for me to find a point of contact, I need to solve this. Basically substitute the first equation into the second equation and then find the point of contact. So in this case, if I try to do that, it will be a bit cumbersome, and therefore what I'm going to do is, let's see, in this I can take out what is y equal to. So I'll have x minus 1 the whole square is equal to 15 into, now y is going to be equal to root of 15 minus x, 15x minus 6 minus 1 minus 6. Now this is the equation that I'm going to solve. Solving this equation is not the subject of interest in this video. The subject of interest is to find the point of intersection, and you will gonna get very simple questions. You don't need to break your head on that. In this case, I'm going to take the point of intersection from the graph itself, and the point of intersection from the graph is given to me as 0.422, 0.422. Now that's the point where these two curves intersect. So what do you do now? You find the slope of the tangent to this curve, which is curve 1, by differentiating this. and substituting the point. So your y1 is going to be equal to 2 into 0.42 minus 1 divided by 15. That's your first slope. Whatever this value is, that's your first slope. And similarly, you find the second slope, which let me call it as m2. Then if you have to find the angle between the two curves, which is curve 1 and curve 2, you simply apply the formula theta is equal to tan inverse of modulus m1 minus m2 divided by 1 plus m1 m2. So you can make a note of this as a formula. This is the formula for finding the angle between the two curves, where m1 is the slope of the tangent to the curve at the point of intersection, and m2 is the slope of the tangent to the curve at the point of intersection of the two curves. And that should take care of the question. If in case you do get any questions, they might ask you what is the angle between the two curves when the slopes are given. Again, I'm not expecting any questions based on angle between the two curves. If it does come, that's how you do. So with respect to tangents and normals, there is only this much that you need to know. Nothing else. Okay? There's nothing else that you need to know. You need to be thorough with your differentiation process. You need to substitute and then get the tangent. What's the idea? What is a tangent? What's a normal? What is the slope? What's the point of intersection? If these things you know, you're done with tangents and normals. Nothing else. I'm moving on to increasing and decreasing functions. With respect to increasing and decreasing function, well, the working rule is very, very simple. You will be given a curve, differentiate the curve. Once you differentiate the curve, you factorize the equation. Factorize the differentiated equation. And then for increasing, dy by dx is greater than 0. For decreasing, dy by dx is less than 0. That's all. This is a simple working rule. Be it algebraic function or a trigonometric function, it is very, very simple. Differentiate, factorize, increasing, decreasing. Let's pick up a simple question, a very simple question. Actually, I'm going to pick up a degree 3 equation. I'm going to pick up a degree 3 equation, then I'm going to come back and explain something else to you. Okay, just give me 1 second. This is good. So let's look at this question here. The question says, find the intervals in which the function so and so. Again, a worked example. The reason why I do the worked example is simply because they can be picked up for your examination. Most of them do the exercise questions and they don't practice the worked example. That's where they lose out. So what's the first step? First step is to differentiate. So let's go ahead and differentiate this. F dash of x. 12x squared minus 12x minus 72. Second, factorize. So for factorization, I'm going to take a 12 common out. So when I take a 12 common out, I get a x squared minus x minus x. Further, you can factorize this by using the splitting the middle term method, which you have learned. So this is 12, x taken common out, x minus 3, plus 2 taken common out, x minus 3. So ultimately, I'm going to have x plus 2 into x minus 3. So you have differentiated and you have factorized it. So remember this. First is differentiation. The second one is factorization. Now you need to find out when is the function increasing, when is the function decreasing. Do not break your head too much on this. Make sure that you write this in the standard form. When I say standard form, it needs to be minus minus on either side. Take the minimum value, which is a minus 2. This is a 3. If it is a minus 3, then this value is a plus 3. Draw the curve. Start with a plus, minus, plus. Wherever there is a plus, it is increasing. Where there is a negative, it is decreasing. So it's increasing in the interval minus infinity to minus 2, union 3 to infinity. Very simple. Yeah. And where is it decreasing? From minus 2 to 3. Now this again, I'm doing this because it's an MCQ based question and you can simply solve it and move on. And that is it. You don't need to do anything else. You're done with this question. Some questions are not straightforward as how I have it here. This is typically following these steps and then you're done. Let's look at a question here. Show that the function given by that is increasing. It's always increasing. That's what it's saying. So I follow the normal steps, which is differentiate, then factorize this. Now the problem with this question is I can't factorize this. I cannot factorize this. This is going to be 12 and then I don't know what to do with this. And here there's a slight change in the working rule. The working rule now will be to show that f dash of x is always going to be positive. So I will try and show that this entire function is going to remain positive. How do I do that? I'm going to take a 3 common out. Use completing the square method. So this is going to be 3 into this entity is x minus 1 the whole square. Minus 1 plus 4 by 3. So you take an LCM and what do you get? 3 into x minus 1 the whole square plus 1 by 3. That's what you get. So when you multiply, this is going to be 3 into x minus 1 the whole square plus 1. So that's your f dash of x. Now what do I know here? I know that this is always going to be positive. X minus 1 the whole square is always greater than or equal to 0. 3 into x minus 1 the whole square is always greater than or equal to 0. So now when I add a 1 on either side, I'll get something like this. What is this? This is f dash of x. So I've always proved that f dash of x is going to be positive all the time, and therefore this function is always increasing. Again, this is being a MCQ based questions, you might get questions something like, prove that this is it always increasing, always decreasing. So you will have this in your mind that, okay, I need to differentiate and say f dash of x is greater than 0, but then you can't do it. And that's when you use this kind of methods. So that's about it. From increasing to decreasing function, these are the two things that you need to know, nothing else. Another few other questions like y is equal to log x. Remember, y is equal to log x, y is equal to e to the power of x. Okay, you need to know how the graph looks for both of them. Y is equal to log x looks like that, y is equal to e to the power of x looks like that, and both are increasing. Both are always increasing actually. You can also confirm this by differentiation. So when I differentiate this, dy by dx is going to be 1 over x. dy by dx is going to be 1 over x. And here dy by dx is going to be e to the power of x. So this will always be increasing. It will not decrease, both. Moving further. Now that's how you deal with the algebraic function. Okay. All of these are algebraic questions. Find the intervals in which the following function is increasing, decreasing. Important question is this, question number 9. Again, if it was a subjective based question paper, you might have got this. Otherwise, straightforward questions like find the tangent and find the interval where the function is increasing or decreasing. Just follow the method that I gave you and that should be okay. Practice all the questions from NCERT. Let's look at one of the trigonometric questions actually. Let's simply pick up this question here. Y is equal to sin x. Okay. Because that gives us a blueprint on how to work on trigonometric questions. That's all. After that, you can apply the same backbone to other questions. So y is equal to sin x. So what do? You differentiate the function. Dy by dx is equal to cos x. Now, what's the next step? There's no factorization involved in this particular question. So you say for maximum or for increasing dy by dx is equal to 0, or is greater than 0, sorry. So cos x is greater than 0. Now I'm thinking, when is cos greater than 0 or cos positive? For that, you need to go back to the ASTC graph. First and the fourth quadrant. Right? Now, what is the first quadrant like? 0 to pi by 2. What's the third quadrant like? Well, it could either be a minus pi by 2 or 3 pi by 2 to 2 pi. Now, when you're doing these trigonometric question, you also need to note the intervals given in the question. That is very important. You can't give the answers based upon your conclusions here. You need to go back and see, okay, what is the interval? The interval given is 0 to pi by 2. Is it increasing? Yes, because in that interval, dy by dx is positive. And what was dy by dx? Cos. Where is it decreasing? In the second quadrant. And of course, in the second quadrant, it will be decreasing, because in the second quadrant, the differentiated function, which is cos x, is negative. And that's it. Pretty simple. So I'm going to show you all the trigonometric questions here. The intention is to tell you that the trigonometric questions will come with an interval always. Again, an interval. Look at this. No interval. Interval. Cos x, trigonometric equation, there is an interval given to you. Keep these things in your mind, that, oh, okay, in these questions, this is what happens. In these questions, this is what happens. Another important question is this. Find the intervals in which the function is increasing, decreasing, go ahead and differentiate this. The NCERT textbook has solved it in a different way. I would solve this question in a different way. What I would suggest is you watch the video that I've made on this to understand how I solve it. Otherwise, you can stick with this also. That's completely fine. Frankly speaking, you can simply remember the values here, which is pi by 4 to 5 pi by 4. Understand this question. I'll tell you something here. Just give me 1 minute. See, the question says f of x is equal to sin x plus cos x. I'm actually going to explain to you what the NCERT textbook has done. So you do f dash of x, which is cos x minus sin x. You equate this to 0. For increasing and decreasing function, we do not do equating to 0. But in this case, I'm going to equate this to 0. So I say cos x minus sin x is equal to 0. So I get minus sin x is equal to minus cos x, which means tan x is equal to 1. Now I try to find out the values for tan, where it is 1. I know tan is 1 at pi by 4. So I draw a straight line. It's 1 at pi by 4. And it's also 1 at 5 pi by 4 at this interval. So you get your 2 points. So now what do? Well, there is 0 to pi by 4. That is your first interval. And then you have pi by 4 to 5 pi by 4. That's your second interval. Right? And then you have your third interval, which is 5 pi by 4 to 2 pi. So you can go with a straight line here like that. So you start with the least, which is 0 here, pi by 4, and then 5 pi by 4, and then a 2 pi. Then a 2 pi. Now what happens? Where is it positive? It is positive like that. So now this is going to become positive, negative, positive, negative. Hold on for a second. Increasing in the interval, this will be fine, and this will be fine. Yes. Decreasing, I would not do this. 2 pi and above, 2 pi and above, I will not do this. I'll only stick with this much. Okay, so this is decreasing from here to here. That's all, over. Nothing much. So using this method, you can solve the question in a very quick way. The intention is to solve questions faster for an MCQ. Okay, and not get lost in lengthy methods of solving the question. If this question is given as an objective type question, and if you do this, you will lose marks. You will not get the full marks because it's been solved in a very simple way. You might have to tweak it a bit and write it a bit lengthier. Maximum number of minutes for one question in an MCQ paper is 1 minute 30 seconds. If you're taking anything above 1 minute and 30 seconds, you are wasting time. Please keep that in your mind. Apart from that, there is nothing much in this chapter. Some of the important questions, the 9th questions, which I've already mentioned, important because students forget to take care of this minus theta. Apart from that, there is nothing much. So we have talked about tangents and normals. We have also spoken about increasing and decreasing function. The next thing is about maxima and minima. Now, why is maxima and minima a bit important? Because under maxima and minima, you have different types of questions, and I've already mentioned earlier. You have the absolute maxima, absolute minima, global maxima, global minima, and the local maxima and local minima. I'll very quickly give you a gist of all of these terms. What is meant by all of these? Again, if you want to understand this, there's another video which I've made in detail about all these things. Go ahead and watch that. This is only exam specific, so I'm not going to divert into anything else apart from that. Global maxima. It's a maxima for all of the function. This is the global maxima. Local maxima. This is the local maxima, local minima. So a function can have multiple local minimas, but one global maxima. For a global maxima, there will not be an interval given to you, but for a local maxima or minima, both. Okay. For local maxima or minima, there will be an interval given to you. And the interval will be given to you will be an open interval. That will be an open interval given to you. And then you have the absolute maxima and absolute minima. For absolute maxima and absolute minima, they will give you a closed interval. If there is a closed interval question, understand that he is asking you for an absolute maxima and absolute minima. So what is an absolute maxima and absolute minima question? He will give you the closed interval. He will say in this interval, which is the maximum or the minimum. So right away, you can see that there is no peak, but the minimum is this and the maximum is this. We will look at all of these questions and look at how the working rule changes. Let's look at the global maxima and global minima first. We'll pick up question 32 itself. Let me give you the working rule for finding the global maximum. First step is Differentiation, of course, so you differentiate the curve. Second step is factorization of the differentiated equation. The third step is to equate to 0. And then the fourth step is to find the values for x when it is equated to 0. Find x values. Find x values. Okay. The fifth step, find out d square over dx square. The seventh step, if d square by dx square is greater than 0, at that particular point, whatever x values you found from here, at that particular point, if it is positive, then at x equal to whatever values you found here, let's say a was one of the values, at x equal to a, f of x has minimum. If d square by dx square at the particular point x equal to a is less than 0, then at x equal to a, f of x has maximum. Remember this working rule. That's all, pretty simple. So I'm now picking up a question. Again, it's an NCERT question, a worked example. So I have f of x as equal to 3x to the power of 4 plus 4x cubed minus 12x square plus 12. So the first step, I simply follow the steps that's mentioned. I go for the first step, and the first step is to simply differentiate the function. So let's quickly differentiate the function. So if I'm differentiating, I will have f dash of x as equal to 12x cubed minus plus 12x square minus 24x. That's what I'm going to have. What's the next step? Factorize this. So how do I factorize it? Take a 12x common out. So you remain with the x square plus x minus 2. That's what you remain with. Further, I can use splitting the middle term here and write this as that, and this is going to end up being x taken common out, x plus 2 minus 1 taken common out, x plus 2. So this is 12x into x minus 1 into x plus 2. If it was an increasing or a decreasing function, we would have done the curve method like that. But this is not increasing or decreasing. This is maximum and minimum. And what's this for the next step after this? Equating it to 0. For maxima or minima, you can write that, or for extremum, you can write that. F dash of x is going to be equal to 0. So what does that mean? I will have 12x into x minus 1 into x plus 2 equal to 0. From here, I get the x values as minus 2, 0, and 1. These are the three values. So what does this mean? It simply means that at these 3 points of x, I will either have a maximum or a minimum. That's what it says. What next? We double differentiate the curve. Do not use this because it has 3 functions, so it will be a bit cumbersome. Use this. So when I double differentiate, I get 36x square plus 24x minus 24. Again, for all of these, you need to be thorough with your differentiation. So, well, you don't need to solve this. You don't need to do, simplify this, take common out, nothing like that. If you want to, you can do it, not an issue. But the intention is not that. The intention is to find out what is happening when I substitute a minus 2. Is this going to be positive or negative? the entire value. It's going to be positive because you're going to get here what? 3 into minus 2 whole square, which is 3 into 4, which is 12. 12 plus 12 minus 4 minus 2, which is going to be a positive number, and therefore I know that this is positive. That's all I need from here. Then f dash of 0. So when I substitute a 0 in this case, what will happen? These two terms are going to vanish. So I'll remain with 12 into minus 2, which is a negative number. And then I have f double dash of 1. So when I substitute a 1, is it going to be a positive or a negative? Let's see. 3 plus 5, 5 minus 2 is going to be a positive number, and therefore this is 0, greater than 0. Now I know that at this particular point, there's going to be a minimum, maximum. That's all. So, yes. But the question says, find the local minimum and local maximum. In that case, you're not finding the x values, but you're finding the y values. You need to give him back the y values, not the x values. Getting me? So the minimum, local minimum. What are the local minimums? The local minimums are occurring at 1 and minus 2. So you find out f of 1. So you find out the what's the y value at x equal to 1, which is using this. So when you substitute a 1 here, this is going to be a 3 plus 4 minus 12 plus 12. Minus 12 plus 12 get cancelled. 3 plus 4 is a 7. So that's your local minimum. What's your second local minimum? At minus 2. So again, you substitute this value and then give the y value. And then local maximum. Maximum is occurring at f of 0. So when I substitute 0 in this equation, all of this is going to go. 12 is what's going to remain. So that's your answer. So be very careful when the question is asking for local minimum and local maximum values. You are supposed to give the y values, not the x values. And that's your working rule for local maxima and local minimum. Another question here, you can see again f double dash of x and local maxima. There's a point of inflection. Basically, at this place where we differentiate and find out if it is greater than or equal to 0 or less than 0. So at times this will become equal to 0. When it becomes equal to 0, you simply need to write it's a point of inflection. That's all. Now, what's the meaning of a point of inflection? How does it come? And all the stuff we are not discussing in this video. Remember what is meant by point of inflection. Basically, when d square y by dx square is going to be equal to 0, that's your point of inflection. That's all. Some questions like these, which is what is this? A modulus function. You need to know how the modulus function looks, and this is the minimum point of the modulus function. The questions asked in your MCQ paper is mostly conceptual. If you do not know how the graph looks, you might have a bit of a difficulty, because if I apply the normal procedure, I do not know how to differentiate the mod x function. I'll get stuck over there. And therefore, you need to remember that this mod x is basically a piecewise function. It's a piecewise function. What's a piecewise function? It's a function made up of two different functions put together. So when I say y is equal to mod x, it is basically equal to minus x when x is less than 0 and plus x when x is greater than 0. That's your piecewise function. So this is a piecewise function, and if we have another equation, let's say y is equal to 3 plus mod x, then this can be broken into two different functions. If I'm using shift of origin concept, then I know that y is equal to mod x, which is something like that, has been shifted to a new vertex, and the new vertex is 0, 3. And therefore, this is going to be the new vertex, and that's going to be the minimum, and I'm done with it. I don't need to break my head on this. Now let's look at the absolute minima, maxima and absolute minima question. One other thing that I have noticed is questions based on differentiability. Wherever there is a peak, this peak will not be differentiable. Remember that. C3 and C4, at x equal to C3 and x equal to C4, the points are not differentiable because it is not a smooth curve. Remember that. This is absolute maxima and absolute minima questions. The working rule for absolute maxima and absolute minima is different. Okay. So what happens in an absolute maxima and absolute minima question? You will be given with a closed interval. Remember this. You will be given with a closed interval. You first differentiate the function. Equate it to 0. Find the x values. Let's say you found the x value as some a, b and c. Let's say not a, b and c. A, b is taken up here. So let's say x1, x2, x3. Some 3 values are found for x when you equate it to 0 after differentiation. The fourth step, we would factorize it. That will be taken care here itself. The fourth step will be to differentiate, double differentiate when we are doing local maxima and local minima. In this case, what you do is find, take the points, you find f of x1, f of x2, f of x3, f of a, which is the end points here, and also f of b. You find all the values by substituting it in the function, whatever the function was. In this, whichever gives you the minimum is the absolute minimum. Find the absolute maxima and absolute minima. Remember this, whenever there is an absolute maxima, absolute minima question, you will have a closed interval for sure. Differentiate, factorize, equate to 0. Find the x values. Then what? F of 1, which is the endpoint. Then f of 2, which is one of the zeros. F of 3, and then the next endpoint, which is 5. Now in this, which is the minimum, 1 is the minimum. That's the absolute minimum. Which is the maximum, 56. 5 is the absolute maximum. 5 is the point where the absolute maximum occurs. So what's the absolute maximum? 56. What's the absolute minimum? 24. That's all. I can show you some other questions here. In these questions, he has clearly worded that you need to find the absolute maximum and absolute minimum. But there are some questions in the NCERT textbook where he has not worded it. In this case, he has told absolute maximum and absolute minimum. But look at this one. He has not told you if he is wanting the absolute maximum or absolute minimum, but the interval is a closed interval. So remember this. Whenever there is a closed interval, he is looking for absolute maximum and absolute minimum. Remember that. Now, the next question, which is a worded questions. Okay. Worded questions, the method is different. The method until you find the equation is different. After that, it's the same process. Okay. So, generally, I'm going to give you a general rule. It's going to be different for different questions, but I'm going to give you a general rule. The general rule is, first you figure out what is a diagram like. What are the shapes involved. Then you identify what are the variables involved. What are the variables involved? Sometimes he might give you height and radius, or slant height, and the height of the cone and the radius of the cone, or circumference of the cone, whatever information that's been given. And then you need to identify what's the maximum or the minimum that you need to find. Of what? Is it asking the maximum or the minimum of the volume, or the area, surface area? What is he looking for? That you need to identify. Generally, there will be 2 variables. Let's take the variables as x and y. From the situation given to you, you will also try to find out the connecting factor between them. Let's say connecting equation. Also in the question there will be a constant mentioned. You need to figure out what is the constant in the equation. Once you're done with all of these, the remaining steps is basically the steps of finding the global maxima and global minima. That is it. Nothing else. Let me pick up a simple question here. I'll give you the blueprint and then we will try to apply this blueprint onto different questions. So let's look at this question here. You see, he has already mentioned the variables for you and the sum is 35. Find two positive numbers such that the sum is 45 and the product is maximum, which means I need to find the maximum or the minimum for this particular equation here. Let me take this as P. So capital P is equal to x square y square. X square y to the power of 5. And then the sum of the variables is x plus y, which is equal to 35. So when I'm differentiating, I don't need two variables. I just need one variable because I'm going to be differentiating this. And for me to do that, I'm going to use the connecting factor and simply say y is equal to 35 minus x. So the product is x square into 35 minus x to the power of 5. What do you do after this? You simply differentiate dp by dx. U differentiation of v. Be very careful with differentiation here. People tend to forget about this minus 1. They tend to forget that, you will have a minus 1. Then your entire answer will change. Plus v differentiation of u. Now what do? Equate this to 0. If you want to factorize this, well and good. Go ahead and factorize it. So I can take a 35 minus x to the power of 4 common out. And then I can take a x common out. So what do I remain with? 5x. This is common out. And then there's a negative. So keep the negative. And then from here I have taken an x common out. So I'll remain with a plus 2 into 35 minus x. You can simplify this further. So x into 35 minus x to the power of 4. And then minus 5x. Minus plus 70 minus 2x. So ultimately when you solve this, you will get some values for x. So what you're going to do is to equate this to 0. So you're going to get x value as 35, one of the values, and the other value is a 0, and the other value is going to be a 10. Other value is going to be a 10. Now what do? You double differentiate and find out what happens when I double differentiate and substitute these points. Obviously, this is going to give you a 0, so I don't need to take this. This 35 is also going to give you a 0 when I'm substituting in this equation. But 10 is going to give you a positive value. A negative value. And therefore, at that point, I will have a maximum. And you find out the x value from here. The y value from here, which is 25. So 25 into 10 will give me the maximum product, which is 250. That's all this means, nothing else. So this is the blueprint. This is how you work with the questions. Okay. I'm not expecting a three-dimensional question to come up for your examination. We will look at the type of questions when we solve any sample paper. But as of now, this is all the concepts that you get from the chapter. What could be different or what could be difficult are these questions 22, 23, 24, 25, 26. From let's say 19 till 26. This can come as a case-based questions. The blueprint is still the same. The blueprint is still the same. So that's your question paper, the sample question paper released by the board. The first question is obviously from inverse trigonometry. Second question is to do with continuity. Okay, I haven't discussed continuity, but I'm going to discuss that using the questions. Find the value of k for which the function defined as so and so is continuous at x equal to 0. When the function is continuous at x equal to 0, you simply need to say that LHL is equal to RHL is equal to f of x. In this, this is a bit of a tricky question. Okay, the left-hand limit needs to be found out, and then you need to equate it to the function itself. I'm going to take up this question quickly and solve it for you. So the function is continuous at x equal to 2, x equal to 0, which is 1 over 2. So what do you do? In this case, the limit of the function x tending to 0, f of x, is equal to the function at 0. So what is the function at 0? At 1 over 2. So this is 1 over 2. That's settled. What happens here? Well, let's see. This is the tricky part. You need to remember this formula. Limit theta tends to 0, sine theta by theta is going to be a 1. This is the formula that we're going to try and use here. Okay. I can't substitute the value for x is equal to 0 right away here because I'm going to have a 1 over 0 situation, which is an infinity or an undefined limit. And therefore, I need to convert this to this form. And how am I going to do that? I'm going to use cos 2 theta formula. Remember, whenever you see 1 minus cos theta, it is 2 sine square theta by 2. And 1 plus cos theta is 2 cos square theta by 2. It is very useful to remember this because these formulas will appear in multiple chapters in your differentiation, in your integration, in inverse trigonometry. It will appear in at multiple places. So the numerator, which is 1 minus cos theta, can be written as 1 minus cos theta is 2 sine square kx by 2. Divided by sine x I have a x over here. I'm going to introduce a x for this, and therefore I'm going to multiply it with the 2 with as x again, so to balance the equation. Now why am I doing this? Because I'm aiming at this equation here. So this will become a 1. Limit x tends to 0 sine theta by theta is a 1. So I can omit that. But I'm not going to do that right away. Because here also I have sine theta by theta situation. But there is no k and there is no 2. And remember this is a square. So I need a k square and a 2 square. So I introduced k square and 2 square. And how am I going to do that? Well, let's take the 2 common out. So I'll have sine square kx by 2 divided by k square x square by 2 square into k square by 2 square. And this further, is multiplied by 1 over sine x by x. And this entire thing is equal to 1 over 2. Keep that in mind. Now this is going to be a 1. Why? Because the entire thing can now be written as the whole square. And therefore sine theta by theta situation, limit x tends to theta tends to 0. This is going to be a 1. This is also going to be a 1. So what you remain with is a k square by 4. That is multiplied by 2. So 2 into k square by 4 is going to be equal to half. Transposing this to the right hand side, it's going to be a, basically a 1. So k is plus or minus 1. That's your answer. Remember these things because, some tricky questions has come up with this. So you need to know how to go about doing the question. And what you also need to notice is the options given to you. He has given you plus or minus 1, minus 1, plus or minus half, and then a half. Please go back and read the question. The value of k less than 0. You see, even after doing all of these, you still can falter and choose option A. which is not the right option because he has given you a condition that k is less than 0 and therefore B is the right option for you. Okay, be very careful with MCQs. Don't think that you know and you're done and you move on. No, please be very careful. Find a point at which the normal to the curve is perpendicular to the line. So the normal to the curve is perpendicular to the line. A very tricky question, I would say. Now, the normal is perpendicular to the line. Understand this. So I have y is equal to x plus 1 over x. And this is the curve. Let's say some point here. This is the normal. The normal is perpendicular to the line, which means this is what? 3x minus 4y minus 7 equal to 0. If this is the situation, then this is parallel to the tangent. And therefore the slope or the slope of the tangent, if I convert this to the point slope, the slope intercept form, then I'll have y is equal to 3 by 4x minus 7 by 4. Therefore the slope is 3 by 4 here, which means the slope of this is minus 4 by 3. So you take the curve and you differentiate. So you get dy by dx is equal to 1 minus 1 over x square. Now this is the slope of the tangent. And therefore you equate that to 3 by 4. So you get 3 by 4 as equal to 1 minus 1 over x square. Transposing this, you will get 1 over x square is equal to 1 minus 3 by 4, which is 1 by 4, which means x square is equal to 4, which means x is plus or minus 2. Getting me? X is plus or minus 2. Now, after you choose plus or minus 2, go back and read the question and see, is there any conditions given to me? In this case, I don't think there is any conditions given to you. Okay? And therefore, you're done with the question. So you choose the option plus or minus 2. Is there a condition given to you? What do you think? There is a condition given? There is. X greater than 0. If you do not notice that condition, you will basically choose the B option as your answer. But x greater than 0, which means I need to pick the positive 2, not the negative 2. Therefore, A is the option. Very tricky. Remember these things. Okay. Next question. This question, 12th question, please remember the answer is minus e to the power of y minus x. A very simple question. Students go wrong in this question. So you have e to the power of x plus e to the power of y is equal to e to the power of x plus y. So what happens here? You quickly differentiate this function e to the power of x plus e to the power of y, y1 is equal to e to the power of x plus y into 1 plus y1. We have a to the power of m plus n is equal to a to the power of m into a to the power of n. But in this specific question, he has told this is equal to that. And therefore, you will have e to the power of x plus e to the power of y, y1 as equal to e to the power of x plus e to the power of y into 1 plus y1. After you simplify this, you will end up with the required solution. Cancels. Again, you open up the bracket here. E to the power of y, y1 is equal to e to the power of y plus e to the power of x, y1 plus e to the power of y, y1. Transpose and you should be done with this. Okay? This of course will get cancelled. So you will have minus e to the power of y by e to the power of x is equal to y1, which is minus e to the power of y minus x is equal to y1, and that's your solution. Very simple. Moving further. We have discussed this question. I've told you how to solve this. Be very, fast. Do not waste a lot of time. Differentiation, we have done. You know how to differentiate. I'm not going to discuss that question. It's a simple question. Please go ahead and do that. Again, another question here. Differentiation. Very simple differentiation. Look at how to do it. That's all I can say. Find the least value of the function. The function is given to you, f dash of x or f of x. And he has clearly mentioned that it's a closed interval. And therefore, he is looking for absolute maxima and absolute minima. You need to be very thorough with what is absolute maxima and absolute minima. I'll quickly solve this question here. So the function given to us is 2 cos x plus x. And the interval, which is a closed interval, is 0 to pi by 2. So what do we do with this? Simple. Differentiate the function first. F dash of x is minus 2 sine x plus 1. And then for maxima or minima, you equate it to 0. So basically, you get sine x is equal to 1 over 2. So when is sine 1 over 2? That's happening when x is equal to pi by 6, which is a 30. So now you have 3 points. So you find out f of 0. F of 0 is going to be 2 because cos 0 is a 1. So this is a 2. And then you find out f of pi by 6. That is 2 into root 3 by 2 plus pi by 6. Which is simply root 3 plus pi by 6. And then you find out f of pi by 2. Cos pi by 2 is a 0. So all you remain with is a pi by 2 here. So you have 3 values. Because it's a pi, it's a bit difficult for you to identify what it's going to be. Well, let's see. Root 3 is 1.71 something. Pi is 3.14. That is divided by 2. 3.14, let's keep it as, 3 itself, which is around 1.5, 1.6. So this is around 1.5 and 1.6. Around that. But this is 1.71 plus some more value. So this is giving you the maximum point. And this is giving you the minimum point. So now you go back and look at what the question is asking for. He is asking for least value. And the least value is at pi by 2. Moving on. Look at that. The real function is increasing, decreasing. Same thing. Differentiate. Look, this is what I was talking about. In inverse trigonometry, you get to use the cos to theta formula. 1 minus cos x and 1 plus cos x. Remember that. 1 plus cos x is 2 sine cos square x by 2. 1 minus cos x is 2 sine square x by 2. Please remember that. Find the value of b for which the function is strictly decreasing over r. So which means that it's always decreasing. So it's either less than or equal to 0. So let's see how to do the 29th question. Question number 29. So, hold on, let me. So we have f of x as equal to. Where is the question? X plus cos x plus b. So I differentiate this function. 1 minus sin x. And the entire real numbers is given to me. I differentiated it. So for decreasing, what do I know? For decreasing, f dash of x needs to be less than 0. Just give me 1 second. Find the function strictly decreasing. So f dash of x is going to be less than or equal to 0. That's what I will have. But now I'm looking at, okay, what is sine? This is a function here. So basically I'm saying that 1 minus sin x is less than or equal to 0. Which means minus sin x is less than or equal to minus 1. Which means sin x is greater than or equal to 1. When is sine greater than or equal to 1? Never. It will never be greater than 1. The sine function, you have to remember, is always between minus 1 and plus 1. It will never be outside of this boundary. And therefore there is no value for x for such that the function is always, going to be decreasing. It's not going to happen. Therefore there is no value for this. Let's go back and look at the options that we have in the question paper. In the question paper we have 29. This, no value of b exists. That will be your answer. Okay. It's a very tricky question. Reason being, generally you're looking for the b value and you differentiate, the b value vanishes. And you draw your conclusion not from the b value, but from the behavior of the sine function. Okay. Remember this question, the points at which the function is continuous. Again, this is something that you need to know. When there is a modulus function given to you, wherever there is a peak, remember there is not differentiable at this point. If it is a smooth curve, it's differentiable. Mod x function has a peak. The mod x function has a peak, so it's not differentiable at x equal to 0. Understand that the mod x function is passing through 0, 0. That's the peak. So if you have the equation as y minus k is equal to mod x minus h, then the peak is at h, k. And it's not going to be differentiable at the point x is equal to h. So this question can be, asked in multiple ways. They might ask you, when is this function not differentiable? Or when is this function not differentiable? Basically, whenever this is going to be a 0, that's when it's not differentiable. So where you say sin x is equal to 0, so when is it? At 0 itself. So at that point, the function is not differentiable. Whereas in this particular question, it's a piecewise function given to you, where x is, you have to really understand this, x by mod x, when x is less than 1 is what is given to you. And therefore, if I try to solve this, then I'm going to get that, which is a minus 1. And therefore, the piecewise function f of x is going to be minus 1 in both the sides when x is less than or equal to 0 and x is greater than or equal to 0. Basically, the function is y is equal to minus 1. And what is y equal to minus 1? Y is equal to minus 1 is a parallel line to the x-axis at a distance of minus 1 unit. So this is minus 1 here, and this is your x-axis. Is it continuous? Yes, obviously continuous all over. I did not lift my pen out of the paper to draw the line. And therefore the function is continuous at that point. The function is continuous all over, in fact, for all x values belonging to R. Please remember this question. It's a very tricky question. Next. Area of the trapezium, area when the maximum. See here, you have the function given to you. You need to differentiate this function. There is no connecting factor as such. There is no constant as such. You simply do the normal maxima or minima question and then you're done with it. Find the points on the curve at which the tangent is. So you differentiate. When you differentiate, you get a 3x squared minus 11. You equate that to 1 because that's the slope. 3x squared minus 11 is equal to 1, and then you find the value for x. But when you're coming back and marking the options, please look for any x greater than 0, less than 0 and all those stuff. This question. This question is a bit tricky. Let's understand this question. The fuel cost per hour for running a train is proportional to the square of the speed generated. It generates in kilometers if the fuel cost is 48 rupees per hour. So there are multiple things involved in this question. The first thing is that he says that the fuel cost per hour for running a train is proportional. So let's take the fuel cost as F. I'm taking the fuel cost as F. And he says that it's proportional to the speed of the train. Square of the speed of the train. So it's S square. So this is direct proportionality. So I'm going to write this as some constant k into h square. Now the next information is also important. The fuel costs 48 rupees per hour. So the cost of the fuel C is 48 rupees per hour. And for that, the speed is given to me as 16 kilometers per hour. So if the train is running at 16 kilometers per hour, then the fuel cost is going to be 48 rupees per hour. And the fixed charges to run the train amounts to fixed charges. This is the fixed charges. Is 1200 rupees per hour. So if it's running for 2 hours, then the fixed charge is 2400. Remember that. Assuming the speed of the train is as v kilometers per hour, what's the situation? Okay. Now he has told you that the fuel cost per hour is k times the square of the speed of the train. We know that already. We found the equation also. F is equal to k s square. Now from this situation, he is asking us to find a value for k. Well, for us to find a value for k, we're going to use these values, which is fuel cost per hour and 16 kilometers per hour. So both are in 1 hour itself. So I don't need to bother. I can simply substitute the fuel cost 48 to be equal to k into the speed of which is 16 square. So what we do next is to solve this. Well, do not square this and then transpose. Simply transpose it like that, because 16 ones are 16 threes is 48, so k is simply 3 by 16. That's your answer. That's the answer for the first question. K is 3 by 16, sorry. Now the next question is a bit tricky. If the train has traveled a distance of 500 kilometers, then the total cost of running the train is given by what function? Now the distance traveled by the train is 500 kilometers. Distance traveled by the train is 500 kilometers. Now for it to travel 500 kilometers, how much time would it have taken? The time it would have taken is 500 divided by 16. So the time taken would simply be 500 by 16. If I divide this, let's not divide this, hours. Let's keep it as hours itself. So in that case, what's the fixed charge? For 1 hour, it's 1200. So for 500 by 16, the fixed charge is given to us as 500 by 16 into how much? In this case, we do not know the velocity. Okay, 16 is the speed for a particular situation, but assuming the speed of the train to be v kilometers per hour. So I'm now going to change the time to 500 by v. And therefore the fixed charge is going to be 500 by v into 1200. See, what's the total cost like? The total cost is fixed charge plus the running cost, no? This is the fixed charge. Now what's the running cost? The running cost is given by this function here, where the speed is v. He has mentioned that the speed is going to be v. And therefore the total cost, which is f, is going to be the fixed cost, which is, 500 by v, plus the running cost, which is how much? 3 by 16 v square. That's the running cost. Now this is the running cost for 1 hour. This is the running cost for 1 hour. But how many hours is the train running for? 500 by v. So that is where this question is tricky, because the cost given is all for per hour. This is all for per hour. So you're going to calculate the fixed cost or the total cost for the number of hours the train is running, which is 500 by V, 500 by V. Now, if you simplify this, what do you have? Where is this? Fuel cost, if I can call that as FC, which is fuel cost. Now, if you want to, you can simplify this. So I'm going to keep this as it is because it's a big number. But I think I can reduce this. Plus, can I reduce this further? I think I can. 4 4s are 16. 4 1s are 4. 4 2s are 8. 4 5s are 20. So 125 into 3. How much is that? 375. 375 V divided by 4. That's the fuel cost. Now what do you do? Speed generates, find the fixed charge. I think that is it. Let's see what else he's asking for. The most economical speed to run the train is... What does this mean now? The most economical speed would simply mean that I need to differentiate with respect to V and find the maximum or the minimum. Yeah? Most economical speed. And for that particular value, I need to find out the fuel cost and then the total cost of the train. So in the question, you have 4 options. You will go with option B because that's the one which has 375 by 4. Obviously, 12 5s is 60, so that's going to give you whatever, that's 6 lakh. And that should be the end of the question. Any doubts with this? The only trick in this question that you need to remember is that the cost that is given to you is for per hour. And therefore, you need to multiply it by per hour. This is for 1 hour. The cost is for 1 hour. So how many hours is the train running for? Time is 500 by V. That multiplied by that. So that's your basic revision of the chapter application of differentiation, the entire chapter itself. And what you need to know to start solving questions from this. Again, like how I mentioned earlier, pick up Oswald sample papers, start solving all the questions from that. One of my students has mentioned that most of the questions are repeating in the sample paper of Oswald. So even if that happens, please go ahead and do it because CBSE CBSE NCERT questions might not be this difficult. This is not an NCERT question, the one which we did right now, but it's in the portion. Okay, so therefore go ahead and try the sample papers and practice them.
So that's the end of the revision. This has been a long video. Thank you for your patience, for staying on for a longer period of time and kind of getting a glimpse of what is the different types of concepts under application of differentiation. This, I would say, is just the beginning of the chapter. As a CBSE student, it is appreciated if you could practice questions from R. Agarwal and R. D. Sharma also. And you can approach me by posting a comment on the comment sections and request me to solve a question for you. I will go ahead and do that. As of now, thank you very much for your patience and goodbye.